Assalamu alaikum. In this video, we are going to solve another question, and this question shown in the screen is typically a difficult one. So, reading out the question, it is given that a cube plus b cube equals minus 56 and a square plus b square is equals minus 4. Find the quadratic equation with real coefficients having roots alpha and beta. So, I suggest that first of all you pause the video and try the solution yourself, and then look at the formal solution yourself if you have finished the answer, or either you can have no idea on how to solve it. So now this is the converse process of what is typically asked in the examinations. Is alpha cube plus we are provided the values of alpha cube plus beta cube and alpha square plus beta square, and then we have to find the quadratic equations with roots alpha and beta. It used to be converse in the previous questions. We were provided the equation and we had to calculate these values. So moving on to the formal solution, we need to find alpha plus beta and alpha beta with the quadratic equation of the form ax square plus bx plus c, with the values of a, b and c being real as stated in the question. So now we are assuming the value of a equals to 1. So we are getting alpha plus beta equals minus b and alpha beta equals c. So now we are trying one case. There are several methods to solve this question. Once you have seen this solution, you can try this question using the other methods yourself, using the theories learned so far. So we are cubing alpha plus beta whole cube, and it will, if we simplify it, it will look like this. Just this process is simpler. We are going to substitute the value of minus b over here, the value of minus 56 over here, and the value of c in place of alpha beta, and the value of negative b in place of alpha plus beta. So we are getting b cube equals 50 minus b cube equals minus 56 minus 3bc. So we are getting 3bc equals b cube minus 56. Now moving on to the second equation, we have to find alpha plus beta multiplied by alpha square plus beta square, and that is equals to a cube plus b cube plus alpha beta alpha plus beta. We are getting minus b over here, we are getting minus 4 over here. That should be equals to minus 56 plus c multiplied by minus b. So 4b equals minus 56 minus bc. So bc is equals to minus 4b minus 56. So that forms our second equation, and that forms a first equation. So I am going to write these equations on the next page all over again. 3bc equals b cube minus 56, and bc equals minus 4b minus 56. So we are going to substitute the value of bc equals minus 4b minus 56 into this. We are going to substitute this expression into this. So now we are getting 3 multiplied by minus 4b minus 56 whole equals b cube minus 56. In short, our equation will look like b cube plus 12b plus 112 equals 0. If we will factorize it, we will obtain b plus 4, b square minus 4b plus 28 equals 0. You can check out, you can do this process using the Riemann factor theorem, and you can complete this process by using the simplification. So on one hand we are getting b equals minus 4, and we have the second equation. The discriminant over here is the value of the discriminant b square minus 4ac equals, now this b is different, this b belongs to the discriminant. You have learned it in P1. So minus 4 square minus 4 128 equals 16 minus 112. So b square minus 4ac is less than 0. So we have no real values for this equation. So we have b equals minus 4. Now since real coefficients are required, so we will only accept the real values. Now using this very formula, bc equals minus 4b minus 56, we are substituting minus 4 over here. Minus 4c equals minus 4 multiplied by minus 4 minus 56, minus 4c equals 16 minus 56, minus 4c equals minus 40, c equals 10. So we get the value, so we get the equation. Therefore the value of a is 1, the value of b is minus 4, and the value of the constant is 10. So we get the equation in the end. Therefore the equation is x square minus 4x plus 10 equals 0. So this was our question number 3. Thank you very much for watching the video. Inshallah, in the next video I will come up with another interesting question.